So we have seen that out of the four operations I think somebody's mic is on. Please mute your mic. So we have seen that search is the most important operation, which is deciding the performance of the database management system as such, as a whole. So if you optimize or if you make the search operation faster, the whole DVMS will become very efficient. So for making the search faster, there are many techniques available. There are many techniques still people are working on, because querying a database or searching in a database is the most crucial operation. Even in the context of big data, search is the most vital or crucial or important operation that one has to think of making it faster or optimizing. Okay, so in that context, there are many techniques available. So in the last class, we have seen the popular indexing technique. So we have seen that an additional file called an index file or an additional table called an index table can be created, and that can be either in the sorted order or it can be in the unsorted order. And we have seen that there are two type of indexing: sparse indexing and dense indexing. So we have seen that in the by maintaining an additional memory called an index table and doing insertion, deletion, sorting, arranging, etc. on the index table, you will be able to get into the corresponding database record easily. So one problem that we have seen is that when we are selecting the index for the index table, we will be choosing some convenient values or convenient fields like roll number or Aadhaar number, etc. But normally when people are searching, nobody will remember even your own. I mean, one will not remember his own or her own Aadhaar number, or roll number will be something which is known to only you, or even your closest friend may not be knowing the roll number. So even though we create index table based on roll number, fields like Aadhaar number, etc., it may not be of much use for others, because searching will be on your name, or it will be on your class, or it will be on your branch, semester, or based on your SGPA. The placement department will look at SGPA or CGPA. They look for people who are more than 8. So the query will be on CGPA and branch, etc. So if you sort it or if you arrange it according to Aadhaar number or roll number, that doesn't carry much meaning. That is one problem that we have seen. Then we have seen that there can be multiple indexes. So primary index, secondary index, there can be many indices. Then we have seen that there can be multi-level indexing, first level index table, then second level index table, etc. All right. And finally, we have seen that trees are a well-known or a very popular data structure, which is a very dynamic data structure. So the index table of the indexing part, that can be implemented in the form of a tree. So the problem with the table structure I think some of you can tell. Saurav, what exactly is the problem with tables when compared to trees? Or can you compare trees and tables as two data structures?
Yes, sir.
Yeah, Saurav.
Sir, in table, if sorted, then we can apply binary search, in each research it is dynamically, I think, managed, maintained according
Okay.
to the size.
So the basic issue is that tree is a static data structure where you have to decide the size of the table. Table is actually a static data structure where you have to decide the size earlier, and then you have to, whether you have less number or more number, that much memory will be allotted. Whereas tree is a dynamic data structure which can grow or shrink as and when less data or more data are there. All right. Now, any other advantage for the tree structure other than this dynamic nature? Avinash Kumar. Any other advantage for trees as a data structure? Avinash responding. Sunita. G. Sunita. Amit. Yes, Sunita. Sunita. No response. Amit. Nagarkoti. Amit.
Hello,
Yeah, Amit. Yes.
sir. In tree we can store data in breathwise.
In breadthwise.
Yes, sir.
It's not a. I mean, when you compare it with table or when you, yeah, from the database point of view, in what way a tree is better? Adhikari Venkadayukta,
Yes, sir.
can you just comment on some properties of tree data structure which are suitable?
Searching would be easier when compared to table, irrespective of sorted or not.
That is one only. So that is, yeah, that is not the case, Adhikari, I mean, Yukta. Actually, I mean, it all depends upon how the tree is. Suppose it is a skewed tree, it is as words as a table, isn't it?
Yes, sir.
Or if you have a tree which is growing in only one direction, you won't get any benefit while searching.
Yes.
And if you don't do any sorting while inserting, like your BST or other things, you won't get any benefit for search operation. Can anyone say the advantage of tree as a data structure in the context of databases? Open to all. Anyone, please?
Sir, for sorted data, we can use balanced trees like AVL or for balancing as well as getting the benefits of binary search.
Okay. Any other answer? Manojna?
Yes, sir.
Any comments from your side?
I think proper.
Yeah, tell me, Manoj. Please proceed, Manojna.
Yeah, I think the balanced property of the trees, sir.
No, tree need not be always balanced unless you go for a specific B tree or B plus tree implementation. I'm asking about the tree structure as a whole. Neetu?
Sir, better visualization. Let's say in the table we have to create different columns for department and then under department faculty students. So in tree data structure, it already given a hierarchical order of defining the objects in the tree. So better visualization.
That doesn't make much of a thing. Visualization is not important for a database when you are querying the database or when you do the database operations. Yeah. Neetu, you are absent?
Sir, sir.
Yeah, then please tell yours.
So and then I also think the height, like for a balanced tree, the height will be less. So the searching part would be easier.
Okay. Yeah, that is what I was saying. Always the tree need not be balanced. Suraj?
Sir, in case of hierarchy in the data, tree will perform better compared to table, sir.
All right. Okay, so the answer that I am looking for is that, as you know, in the case of a tree, insertion of data, deletion of data are all very easy. In a big tree of 10,000 nodes, you can probably add another tree, isn't it? For inserting another tree into an existing tree, you need to only change one pointer, or you need to make a pointer point to the root of the new tree, isn't it? Or if you want to remove a whole tree from or subtree from a tree, you need to make only a pointer null, or you just make a pointer point to some other location, so that the whole tree can be logically moved into another tree. All right. So adding a big branch or adding 10,000 or 15,000 data as a subtree can be done by just readjusting a pointer, or cutting a big tree can be done again by making one pointer null. So you are not physically moving the data, or you are not doing you are not disturbing the existing data. So without disturbing physically the existing data, insertions and deletions can be done very comfortably. So that makes tree a very suitable choice in the context of databases, because even none of the other data, existing data will be affected. Or sometimes when you are deleting, only the parent node or the sibling node will come to know that there is a new data which has been inserted. 90% of the existing data will be undisturbed. So that is actually the advantage of applying tree structure in the context of database storage. Any questions or comments on this? Do you agree, or do you have any counter arguments? Anyone? Abhinijit? Abhinijit? Yeah. What was the point I was trying to make? Can you just tell?
So my network is down, sir. I'm not able to.
Okay. Piyush Keswani?
Yes, sir.
Yeah. So what is the point that I told? I mean, what was the point that I was telling about tree?
Sir, you were telling that advantage of tree data structure is that insertion and deletion is efficient as compared to table.
Okay, insertion and deletion can be done without disturbing physically the existing data.
Yes, sir.
Yeah. Do you agree with that?
Yes, sir.
Yeah. In a table, if you want to insert an element in the middle, you have to shift all other data.
Yes,
And
sir. After that, all other elements are to be shifted.
Yeah.
Yes, sir.
But if it is a linked list, then there is no problem. But if you are implementing a table as an array, there can be an issue. Similarly, if you have deleted 4 or 5 elements, you have to again, push the data so that the holes or the deleted memory locations are filled with the data. All right. So no rearrangements are required after an insertion and deletion. Of course, some are. Yes, Vishal.
Sir, what if we have to delete the root node itself? Then the rearrangement can happen of the nodes in the tree, right?
Yeah, even if you remove the root, you will be replacing it with a suitable node from the child nodes, isn't it? So only that portion will get affected.
Okay, least amount of nodes getting
Least
affected.
amount of nodes will be affected.
Okay,
So
yes.
sometimes maybe few nodes, or there are some worst cases where it will get reflected up to the leaf node, but that is very rare. In most of the cases, when you remove even the root node, removing a leaf node is not going to bring any disturbance. But if you are removing the root and replacing it another one, some slight disturbance will come for one or two nodes, but that will be very much limited. It will be contained in one or two branches of the tree. All
Okay,
right.
sir. Okay.
So please note that point. So that is why tree is a universal choice in many of the applications where you want to do updations and deletions, etc., without disturbing existing data. All right, so we will come back to this topic later. So what the point where we stopped in the last class was that in the indexing concept, the index table can be implemented by means of a B plus tree, balanced tree. Okay, so the points that you were making were correct. In the case of balanced tree, there is a balance property where all nodes, leaf nodes, are at the same distance from the root node. So if you store the database records at the leaves, you will be able to quickly locate them, or you will be able to locate them with equal amount of time. So we will continue about B trees and B plus trees in the next class. Okay, so today we will have a revision on data normalization. All right. So I have a question here at the beginning. So if you are given a specific problem and you are asked to design a database for that particular modeling for that particular application. So will there be one design, or will there be only one design possible, or there can be many designs possible? Tanya? Tanya?
Yes,
Go
sir.
ahead.
Yes, sir. Many designs possible.
Many designs are possible. So how do you compare those designs? Sadish Kumar, how do you, Tanya was saying that there are many designs possible for a given application. So how do you compare them?
Hello, sir. I'm audible?
Yes, you are audible, Sadish.
Sir, according to requirement.
Yeah, assume that both the designs are meeting the requirements.
Then any of work.
Okay. What? What, Sadish?
You can choose any one of them then, if both are requirement are
No, but
satisfied.
say, so I got 5 designs, say one from Sandosh, one from Sarida, one from Sahil, and I got a 4th design from Saurabh Kumar. Yeah, then I would like to choose one among these 4 designs. How can I choose? You are saying if all are meeting the specification, choose any one.
Yes, sir. I don't know, sir.
Yeah, so actually there are some ways by which you can compare the database designs. So some designs, we say they are good designs, and some designs are called bad designs, or designs which are not that good. All right. So the thing is that one parameter by which we measure, can anyone say how do you classify these designs, good, better, bad, etc.?
Sir, based on normalization, which satisfy maximum normalization.
All right. So Saurav, yeah. So
And redundancy also.
Redundancy, yes, sir.
which
Redund-
eliminates redundancy.
Okay, yeah. Yes, yes. 1 second. Okay, so yeah, you are correct. I mean, normalization is something which is based on the redundancy or duplication of data. If you are having lot of data duplication, that can be one parameter by which you compare the designs. A design which is having less, a design which is having less duplication or less data replication will, I mean, normally considered as better than one which is having many data duplication. All right. Okay. Any other views?
So less dependency among the columns or attributes.
Yeah. What was the answer? Hello. Please repeat.
Sir, according to the usage,
According to
Less dependency.
according to,
Less
dependency.
dependency
Okay. Less dependency.
among
Devendra,
the
you were telling.
attributes or column.
All right. Okay. Yeah.
sir,
So yeah.
yes,
Yes,
sir,
Devendra.
according to the usage, sir, if we want to operation, for example, read operation more, or we want to write operation more, we can design the table. For example, for read, we have to structure so that the table is divided less, so the read timing will be less. And for writing, same. We have to design the database such a way that the operation which taking more on the or frequent in the database will take less time.
Who is speaking?
Devinder, sir.
Devendra. Okay. Yeah. So, but we may not be knowing whether more read operations or write operations are going to happen. Always. I mean, you are correct. In some applications, say you may be having an idea, but always you may not get an idea. And you cannot design the table based on the operation, isn't it? Read or write. You are saying the design itself can be based on the read and write frequency. Is it
Okay.
so? Is it so, Devendra?
Yes, sir. Yes, sir.
All right. So we have seen that replication anyway. I think all of you will agree that replication is a parameter which is very important, and data replication creates a lot of problem in the database design. So can Megha say what is wrong if there is a lot of data replication? Megha? Yes? Yes? What is wrong? If
Repeat the question, sir.
I did not hear, sorry.
Sir, please repeat one.
Okay. So there, I mean, already I think Chetana is saying that there can be, let me see, chat box. Yeah, I think, yeah, Chetana is saying data can be inconsistent, different anomalies in the database according to Vivek Roy. Okay, Vishal says for same query, there can be different results. All those things are correct. Actually, if you have multiple data, queries will become inconsistent and you will get different answers for the same query from different parts of the database. All right. And there will be wastage of memory also. So data redundancy is actually a major problem that is coming in the database designs. So good designs will have less redundancy and bad designs will have probably very high redundancy or replication of data. Okay, so but at the database design level, I mean, how do you come to know or how do you comment on the redundancy level? By looking at a database table, say I have a design submitted by, say, Anaka, and I have another design submitted by Amit for the same problem. All right, and yeah, how do I compare these two? Or let us say Ajwad has given me a third design. I have three designs, one from Ajwad and one from Anaka and one from Amit. So how can I have an idea regarding the redundancy present in the table? By looking at the design, how can I understand that? Any comments on that? Open to all. Piyush, Abhishek.
Like a dependency, we can see partial dependency, transitive dependencies.
Okay. Yeah. So in general, we can say that when you are giving a database design, you should also give the meaning of the data. Okay. So simply the syntax of the data is not enough, or simply the database table schema or the designs are not sufficient. You should also give the meaning of data. For example, in a class, every student is going to have a unique roll number. That is the meaning of roll number. There cannot have two students with the same roll. And also I say that there can be multiple students studying in a class. So BTech or MTech, CSE, IS, there can be multiple students in the same year. But one student cannot be in two different courses, two different programs at the same time in the university. Means you cannot be a BTech student as well as an MTech student. All right. Or I can say your CGPA will only be a single, a unique number. I cannot say that your CGPA is 8.5 according to the department and your CGPA is 8.9 according to the placement department. Such things should not happen. So that is actually called the meaning or the semantics of the data. So by looking at the meaning as well as the syntax of the data, one can comment on the redundancy of the data. For example, if I say that in the context of context of hostel accommodation, every student is eligible for only one room. If your name, so if the name of Rahul Sony is coming in 5 different hostels or in 5 different rooms are allotted to him, then I can say definitely that is wrong, because a student in the institute is eligible for only one room. Or when I say that hostel room number, I will be able to find out immediately who is actually the person staying in that room. But if it is a double room, I may not be able to do that. I mean, I will say that it is PG2 hostel, room number 32. If there are 2 students, then from the room number, I may not be able to uniquely tell the name of the student. But from the name of the student, I will be able to tell the room number allotted to him. So this is what this is what is meant by the meaning of data or the semantics of data. So this can be expressed in many ways. And the thing that you told that functional dependency or dependency is one of the ways by which we can express the meaning of the data. Okay, remember, so database designs can be compared based on the different parameters, and one important parameter is the data replication. And by looking at the semantics of the data, you will be able to say, you will be able to comment on the redundancy which is going to be present in the table. All right. Suppose, so the redundancy can be identified or it can be guessed through the presence of, through the functional dependency concepts. There are many other ways also. We will come to that. All right. So in order to reduce or in order to measure the redundancy present in the table, in a database design, a theory which is actually called normalization theory has been developed. So if a particular relation or a database table is satisfying certain criteria, certain conditions, we will say it is in a specific normal form. So normal form is actually a logical state in which a database table can be based on the amount of redundancy present in that particular table. So I have different conditions for different normal forms. So if a particular database table is satisfying those conditions, then conditions regarding the redundancy, then I will say that this particular database design is on this normal form. So there are many different normal forms available from first normal form onwards up to fifth normal form. They are called 1NF, 2NF, 3NF, 4NF, and 5NF. And in between there is something called BCNF or Boise code normal form. So what exactly is a normal form? Can anyone just make it clear so that we can go further? What is actually a normal form? What is the definition that you have for a normal form? Pulkit Joshi. Pulkit.
Hello.
Yeah.
So normal form specifies that what kind of anomaly is removed from a particular form of a particular relational model.
What is a normal form?
Sir, it can be considered as a criteria that sets the level of data independence, data dependence and independence in a table.
Okay. Rocky. Can you add something more to what Ramesh is saying? Rocky. Not present. Sahil.
Yes, sir. Sir, normal form specifies that at what level the redundancies are reduced in a database.
Okay. So normal form is actually a logical state in which a database design is. So that logical state is defined based on the level of redundancy present in the table. All right. If there is certain level of redundancy, you say it is in first normal form. If that redundancy is reduced, then probably it may go to the second normal form. And if the redundancy is removed further, it may go to third normal form. And fourth normal form will have still lesser redundancy. And fifth normal form is normally considered to have the lowest level of redundancy. All right. So depending upon the redundancy, you say a particular database design is in a specific level. There is a logical state in which a database design can be in. All right. Okay. So when you go higher in the normal form, you are removing the redundancy more and more. All right. So third NF, 3NF is having less redundant data than 2NF and 1NF. And similarly, when you have 5NF, you have less redundancy than 3NF, 4NF, etc. So high normal form means it is a good design, and low normal form means the design is not that good. So you can compare the different designs for the same problem based on in which normal form the design is. And normally, if you have a higher normal form design, then you say that that is going to be better. Will that be always true, Santosh Kumar? A higher normal form will always be a better design or can be considered better all the time? Santosh? Absent Sarita?
Yes, sir.
Yeah.
Sometimes may depend on application.
Depends on application.
Yes.
Okay.
Reduces redundancy, but
Okay. Shyam Mohan?
Yes, sir. I think it's a better form.
Always better. Higher
Yeah.
normal form is always better. Saurav Bandobadhyaya?
Yes, sir.
Yeah.
I think not always, because some properties might be violated, like dependency preserving property I have studied in BTech.
Which property will be violated?
Like if we go from 3NF to BCNF, sometimes the dependency preserving property may be violated.
That should not be allowed in any case. Then it is logically error, logical mistake. You have to preserve the dependencies in any case.
Yes, sir.
But
But
as
it
to
reduces
design,
redundancy, but sometimes dependency preserving is violated, I think.
all right. Okay. Dependency, let us assume that now dependency is lost or all dependencies are preserved.
Okay.
Then will you say that 5NF design is always better than an equivalent 3NF design for the same problem?
Yes, sir. Then it is better.
Okay. So actually the thing is that when you go high in the normal form, the number of tables will be more. So the tables will be split and split and into smaller tables. And finally you have a bunch of tables or you have large number of smaller tables. All right. And maybe when you are in 3NF or 2NF, you will have large tables but less number. So here the point is that when you have a collection of smaller tables, for answering a particular query, you may have to frequently join all these tables, right? So joining the smaller tables frequently can take more time, especially in the context of distributed databases. So I have 100 small tables, but the design is in fifth normal. I have another 10 tables, but the design is in third normal. So sometimes in some applications, the 3NF design will be chosen because in the 5NF design, I have 100 tables, but for answering every query, I have to join those 100 tables. So that may take, more time. So don't always, please don't think that always a high normal form is going to be a better design. It all depends upon how the data is stored, where it is stored, where all are at single place, whether it is in a network, etc. All right. All right. So we have seen regarding semantics of data, we have seen regarding redundancy of data, and we have seen regarding what is actually a normal form. And we have seen that being at a higher normal form doesn't always mean that it is a better design. But in general, from the point of view of redundancy, if you go high in the normal form, the design is considered to be better. Okay, let us see the condition for first normal form, which every one of you are aware, I am sure. So here the condition is that the domain is atomic. If the elements are considered to be indivisible units. So every field is having an indivisible item which cannot be divided further. Then you say that it is an atomic item. And in the case of first normal form, all the individual fields should contain only atomic values. So look at the second bullet. A relational schema R is in the first normal form if the domains of all attributes of R are atomic. Okay. A relational schema R is said to be in the first normal form if the domains of all attributes are atomic. So this is by definition. By the set theoretic definition, all individual values should be atomic only. So non-atomic values complicate storage and encourage redundant or repeated storage of data. So a set of, as an example, if you have a set of accounts stored with each customer and a set of owners stored with each account, that will become complicated. For example, in an account, you have a set of customers, or with every customer, you have a set of account numbers, then that can be a problem, or that will be an issue in the database implementation. So that is actually not allowed. So you have customer name, account number, and if you have multiple account number, again another row, customer name and account number. All right. And if an account has got multiple owners, you have the account number, then the customer owner name, then again the next account number, and the owner name, like that. All right. So, or you can say that there cannot be multiple values in a particular column. If that property is satisfied, then we say that a relation is in first normal. So this is a simple definition for first normal form. I am sure all of you are aware of this. All right. So in the next class, we will see about other normal forms, and we will see many additional or